Hello YouTube, iFixItAll here, Team iFixItAll. Today we have a blender, glass jar, container, whatever you want, whatever they're called. And the brand is Waring Futura 900, whatever that means. Waring, solid state, with all kinds of different buttons. Completely mechanical. This is Blender 76 model 11-020. Made in New Haven, Connecticut. Oh no, New Hartford, Connecticut. Waring Products Division. Even has a serial number on it. Got this at Goodwill. So, functional test. Whip. Huh. Regular blend. Flash blend. Oh, that gives you the ability to momentarily that button's a little sticky right there. Okay, so we got to do the chop. I'll do this with a dry erase marker. I'll pay attention to the chop. The chop function is a little stickified, but that means everybody will get attention. Let's see what we need to open this thing up. What is that jingle? Really? Two little fake, those little, what are those nuts called that are stamped out of sheet metal? Let's see what kind of maintenance this thing needs. Hang on. Let's see what's in there. Okay. Small parts bin. What? That easy? Okay. Put that right there. Looks like I could add a little rubber foot to each one because I'm missing two rubber slipper jobbers, buffers. I think I'll do that. I've got something I can glue in there on each one. Well, that's metal. Does that come apart? Is that a screw? Does that even come? I mean, let's see if that's a nut. Yeah, it is. It takes a socket, so that can come out. It's just very in there. All right, we got ourselves a motor, various speed controls. How does this here flash versus regular work? Just a contact that swings around and enables another feature. Yeah, it just comes around like a little wiper switch and hits that this copper contact right here. Using a non-copper part. What is it doing? Let me take a look at this. Oh, I see. So there's our off button. So this is not a contact. It's like some sort of Bakelite tab that when you, that's off. I'm going to choose another feature and watch what happens. This little contact comes out and it remains out. That's on the setting where it's on regular blend, where it's, you push the button in and it stays on. But then if I go to flash, flash pushes that over. So that's off. No, that's not off. This is off. So if I pick a feature, that little Bakelite thing pops out. And if you turn this, it pushes it back in and disables the full, automated thing, which is push the button in and it stays where you set it, versus momentary. Interesting. Well, let me get this motor off, I believe. Let me see what I can do to do some maintenance. Hang tight. So in order to get the motor out, it looks like I had to sneak under there with a angled needle nose and unscrew this off, which is looks fairly new. Now I can get some stuff out. I feel compelled to make a wiring diagram. Yeah, let me do a wiring diagram. So I stare at this and I notice they tell me what color wire to plug in where. The problem is, like I'm not going to be able to show you real well, but like for this blue terminal, it's written right underneath it. It says blue. This one says green. This one says YEL for yellow. This one says OR. But then you have other terminals that say like DBRO. But it's got a dark brown, and then there's a component here which looks like a diode. And the diode plugs in up to here. This one says violet. That says red. This one says LBLK. I don't know what that looks like. Two blacks to me. I'm gonna write them all down anyway. Yeah, smart thing to do. Okay, I've got my terminal numbers written down, 1 through 15, 1 through 8 across the top, and 9 through 15 down along the bottom. I can use this as a guide now to start unplugging everything. Yellow, green, blue, yellow, orange. Everything is pretty much labeled except for a couple of oddballs. Okay, looks like we're all disconnected. I've got 2 Phillips screws here. Lift this motor out. Actually, before I lift the motor out, I should mark something as a keyway. So I'm going to make sure that that matches that. Got a mark there, and I've got one all the way up the side of the motor. Yeah, that should be sufficient. Oh, there's my magnets. There we go. Go fish. There we go. We are out. I think the first thing I want to focus on, would you believe I've had this thing plugged in the whole time? I just got zapped. All right. This is called Arc Less. It's stamped into the Bakelite here. It says Arkless USA, Underwriter Laboratories listed. Horsepower rating. It's good for 18 amps at 120 volt AC and 1.25 horsepower. And then if you're European, it's 2 horsepower at 240 volt at 15 amps. So it draws less current because you're pulling a higher voltage. So, and you also can use smaller cord wire over across the pond as well. Let me do a quick study on this here switch to see how it comes out, because it's not really obvious to me right now. I'm thinking I have to bend these tabs and find out why chop. Or how can I lubricate the switch a little better? Be right back. So to get this switch off of here, it's become pretty clear to me that I have to remove this wearing label. Lucky for me, there's lots of opportunities. See, everywhere you see that's gold is an area I can gently push on, and I can work the label off. So I'm crossing my fingers, hoping that I don't destroy the looks of the label. Be right back. Tricky. I have to figure something else out. I need a homebrew putty knife. Hang tight. This should be almost perfect. I would think. Somehow I feel like this is one of those it was better left alone. Let me wrestle with this for a little bit. Might take a minute. Still wrestling. It's a good modification you should do to all your putty knives. Because when you put it down inside of a can that has one of those hammer-on lids and it has putty or something in it, you can always get underneath the rim of the can and get those last morsels. Kind of like when you're getting peanut butter out of a peanut butter jug. There's always a bunch right up around the rim. Butter knives aren't shaped the right way to accommodate that concept. I've been accused of having a lot of patience. Oh, I knew it was 2 screws holding that thing on. Minimal evidence that we touched it. 2 screws. Yeah. Get that switch out now. What I'm after is to do maintenance on that switch. Whether it needs it or not. Forgot to mention, this is a early 70s model blender. Oh, and let me see. I forgot to. I've got it's a 50-50 shot, but I got to make sure I put this in the correct way. All right, so when it's upside down, I can read all the writing, but I'm still going to tick mark which side is up, or which side is down in this case. Which side goes to what direction. Alright, so, why isn't it? Oh, there it goes. Okay. I'm not taking this out. I don't see a need to at the moment. You know, for the amperage rating, 18 amps at 120 volts, that would make a good, you know, I've got a bin full of switches. This would make a good controls switch to operate different functions, just as it's doing in the blender. But, yeah. Let me see how this thing opens up so I can add some electrically approved lubricant to it. Alright. This is what we call risk management. The way these electrical tabs are installed, they are dropped in the switch, but they are pinched off on each side. They're come down with a crimper that kind of chops into the far right and far left hand side of each terminal, and they're flared out. This little corner right here is flared to the left. This little pinch point here is flared to the right. This is flared to the left. That's flared to the right. The other side of this same terminal pokies out over here, and it's this side is flared to the right. That's flared to the left. This is flared to the right. That's flared to the left. That's because the slot is only so long, and you're spreading out some metal on each side to stabilize the terminal and to keep it in place, but in return it also acts as a rear cover retainer. So, and I am hoping you guys can see what I'm describing there. The far left edge and the far right edge of this terminal that pokes through here. A crimping device has come down to cut through the far left and the far right on both sides in one complementing motion to trap that terminal and keep this rear cover on. So I'm not going to open it. I'm going to lubricate it by slipping in through here and see if that helps matters. I'm going to move to the electrical motor because I heard some jingle jangle in there. Not sure what it is. I don't know what that is. Something's goofy in there. I gotta check that out. That can't be right. What is that? Oh, wow. It's a good thing I dove into this really deep. The fan has come off somehow. Gotta check that out. The fan has come... There's the jingle jangle. Gotta open it up now. The fan is flopping around. Gotta figure out why that happened. Gotta fix it. Be back in a second. Now, before I dive into taking the motor apart, I'm going to engrave which color wire is in what slot. I've just learned this from the past. So I'm going to be engraving into the housing so that when I open the motor up, the wiring, I can dress it back in the way it was. So I've got, where's a magnet? How you doing? This way I can organize this entire harness back the way it was. Yeah, I'll be a second. There we go. Get them all etched out. Who they are. Let's get this thing opened. I hate opening motors. They can always go sideways on you. I'm assuming this thing opens up in the middle. Can't even see a gap. Well, I'm going to mark it. There's my alignment point for my reference. Might even fill it in with some Sharpie here. Alright. Let's keep moving along because it looks like all I need is a little socket right here to dislodge everything. And open it up. Let's see what we can come up with. I wonder if it's metric or standard. It's got to be standard. Let's see if I can find a metric equivalent. Not that I prefer metric, it's just that I know I need a deep well. That ain't gonna work. Alright. Let me do some digging for a deep well standard. Looks like I can get it like so. Oh, come on. I don't know if that happens. There's the nut. Seemed kind of loose. That's never good. Okay. Here we go. Starting to get a crap ton of tools all over the bench again. Let's see. Yeah, so down in the motor, there's a set of brushes that's spring-loaded. When it comes time to setting the motor, putting the motor back together, you've got to trap those brushes back so you can finish putting it together. Why is that motor so hard to turn? Where's my vampires? It's awful hard to turn. Should be more free than that. Oh, we also got these internal tooth star washers. Internal tooth star washer. How do you come apart? I think I see it's trying to talk to me now. I see it splitting in twos. Maybe if I bent the harness back. Yep. Oh, it looks like the brushes aren't going to give me trouble. At least I don't think. I've got to carefully extract everybody. One at a time. Hang tight. I don't think you guys need to see me fight with this harness. The yellow. I can't do the black because it's crimped on. It's trapped. I could split it, but I don't really want to disturb that if I don't have to. Purple, green, and looks as though this brown will come out as well. And oh, I see what's going on. Ooh, that's fragile. This gets to be real careful because that black wire is just, it's tied to the one of the windings on this delicately clipped on section of the terminal board right here. Kind of wish this was wire nutted now right here. I can slip that off. Let me think. Hang on, be right back. So I should mention, as I was disassembling, the brushes have already slipped out because the collector back here is that way too far. But I need to take these two nuts off right here in order to finish extracting the entire housing. So what I've done is I've marked the exterior housing to the inside iron core of the motor. And I should be able to pull everything out. I've got this nut and this nut. It may end up being a stud, which I think it will. I pulled along with it what appears to be a lock washer. Interestingly enough, one lock washer was copper looking and the other one is not. You got to pay attention to all these little details, including are they identical when you take them out. I'm going to stare at this for a second and see why this one had a different lock washer. I don't understand why, so it looks like it's just superfluous. Oh, there's a spacer bushing. Now I should be able to pull everything out of here. Oh, beautiful. This lets me retire this for a little while I can focus on this. On an earlier video, I was talking about a mixer that the collector wasn't worn. That's the part that these brushes ride on. The brushes have tried to go AWOL on me here. They're trying. These brushes are spring loaded up into here. And those brushes create the excitation field to spin the motor. But they rub on this constantly, and as you can see, there's a lot of wear on this. That's from the brushes, because brushes are pretty much 100% carbon. Now my objective is to get this part out of here and find out what happened. Ugh. Okay, and there's another complementary washer. These are Bakelite washers for thrust. They're not metal. There was one on the other end that I didn't show you, but they're made of a material that's usually used to shim a motor. When it overcomes its forward and back thrust, it'll act as shims. Pretty durable too. There's the other one that was in the rear. So there was one in the rear and one up front, or two up front and one in the rear. No, there was three up front. Wonder if I was supposed to only have, I'll figure that out in a little while. There's 4 total. 3 up front and 1 in the back. First things first. What in the hell happened with this fan? I'll be right back. I really don't know what happened here. I just don't know. Goes that way. Sits like this. And I've already forgotten which way this goes. What's really peculiar is this shaft is splined out. And it's trying to talk to me like there was a bushing that was inside this that you just pressed this on. I might have to make a bushing. Then I gotta get this fan the right way. Yeah, I gotta eyeball this. I'm gonna have to do 2 parts on this video. I screwed up and pulled this fan out before I marked which way was up and which way was down. So let's see, I'm vented on the bottom, so that means air would be pushed out the bottom, I would think. I don't know how it can get its oxygen source. Oh, I see. It sources from the bottom. It may not matter which way it's going, which way it goes in. If I recall correctly, let's see, I'd have to take the video apart. I think it was, there's a witness mark there. There's been some grinding going on. So what side is that wide? I got some figuring to do. Be right back. One thing we can talk about is the way these motors spin. They're on like a bronze bushing. It's not just a cylinder tube, it's a round ball that has a hole drilled in it. And the way they have this installed, it's trapped, and the aluminum was crimped over this washer that's holding it. Because watch this. See how I can move that? So if you ever take a motor apart and you run into something like that, you can see what's going on. This doesn't allow for any lubrication. Let's see if I can get that up in there. Maybe it doesn't go up in there that far. Okay. So there really isn't any lubrication other than it just spinning against that bronze bushing. I can add grease and such, but I will lubricate that bushing as best as I can with some oil to get it moving more freely. I think what I have to do is make a new bushing, but it has to be real thin wall. There's not a lot of wiggle room. And I found something I think will work. This tubing, I've just got to make the bushing and trim it and press it on and do a couple of fit tests and see if it's going to be sufficient. Let me make this bushing. Hang on. All right, let's start with this. Deburr it a little bit. And I know I need to cut it right up the side because it's obviously too big for that. We're going to put it on a weight loss program here. And then we're going to take some away now that I have it split. We're going to remove a little bit and do a test fit. It might be pretty close. It's a little bit more taken off. See if we can get it to fit up in the fan blade. Now it's time for fine-tuning it. See if we can get a file to work on this. Getting closer. Try not to let it get crooked either. Can't believe it's still not going in there. Okay, that's in there. Now can I put it on the motor shank? Hammer. Ooh. No, I don't know if that's going to work or not. I need something to press with. Cylindrical. Socket. Oh, it's tight. Well, hate to do this, but we'll give it a shot. Let's try a little hammer here. Okay, so now we can see what malfunctioned. And it's also telling us that my bushing is too thick. I may go with something more rubbery, but it appears to me like I have to at least be able to get this fan blade down to these ribbed sections. That's probably what the bushing, the previous bushing, was frictioning on. But now I've got to examine this bushing and see what failed. So yeah, it ripped. I gotta find something thinner. Stay tuned, part 2. See ya.